My name is Neema Mduma from the Nelson Mandela African Institution of Science and Technology. I'm here to give a talk on an Ensemble Predictive model-based prototype for student dropout in secondary schools. I'll start with the background information and motivation of this study. So this presentation is based on the story about Neema. You can see her from the picture. She's an African girl who studies at Mwendombele Secondary School, which is located 10 kilometers away from her home. She wakes up early every morning to help her mother with family chores before going to school. Her father is a peasant who thinks that school is a waste of time for girls, and she wants Neema to get married instead. Generally, she has a busy parent who don't have time to check for her exercise book or to discuss with the teacher about her school progress. Due to this and several other challenges, there is high possibility that Neema will drop out of school. The story about Neema reflects the life of many girls of school age in developing countries, particularly in Africa. A growing body of literature reveals that there is high dropout rate, especially pronounced in the developing world, whereby girls tend to drop out more compared to boys in different parts of the world. For instance, in Tanzania, over 30% of girls drop out before reaching Form 4, compared to 15% of boys. And this problem has been attributed by various reasons that can be categorized into economic factors such as parental investment, house level factors such as female participation in household activities, cultural factors such as early marriage, and school level factors such as school distance, just to mention few. On the other hand, machine learning has gained much attention on addressing this problem of student dropout, whereby different machine learning techniques has been used. However, most of those studies has been conducted in developed country using developed country data sets. And there is need to address this problem in the context of developing countries due to the fact that there is other features that are applied in developing country that cannot be applied in developed country data sets. So on carrying this experiment, we work with two different data sets. We have school level data set and student level data set. For student level data set, it was collected by Uwezo organization for the aim of assessing education within household in Tanzania. And for school level data set, it was collected by the President Office, Regional Administration, and the local government in Tanzania. For the case of algorithms, we work with 4 algorithms to represent a linear neural network, ensemble, and instance model. Therefore, we work with logistic regression, material perceptron, random forest, and k-nearest neighbor. On evaluating performance of the model, we work with geometric mean, F-measure, and adjacent geometric mean. Our dataset was having a sample about 61,000 and 18 features. And we checked for the dropout distribution, and we found that our dataset was highly imbalanced, whereby the dropout class was only 1.6%. So on handling data imbalance, this problem, we applied different approach, and we observed that Smotin data sampling approach, it performed well with our dataset. So the overall experimental procedure has been summarized in this diagram, whereby we divide our dataset into 60% of training, 20% validation, and 20% of test. And we apply sampling approach to the training set and build the model. We then observe the well-performed model, we tune those well-performed model, and then we evaluate performance of the model using unseen test set in order to observe how the model behave in a real environment which was in balance. Coming to the result, for the feature engineering experiment, the aim was to check which feature shows high contribution to the dropout prediction, and we did permutation of the feature importance score, and we observed that student gender shows high contribution to the dropout prediction, followed by other features such as a parent check the child book, meals per day, a student who read books with a parent who discuss the child's progress with the teacher, and student age. So those are the 6 well-performed features which shows high significance to the dropout prediction. For the case of algorithms, we observed that logistic regression and material perceptron showed better generalization results. So the best approach was to tune this 2 well-performed model in order to improve the predictive performance, with the consideration of the following model parameters based on these 2 well-performed features. And then we combine these two well-performed models to come up with an ensemble classifier by voting approach, which is softly combining those two well-performed models. And then we observe that the stacking classifier, it shows considerable better validation and test result, followed by the tuned logistic regression. Thereafter, we went back to the field and we conducted a roundtable discussion with identified key stakeholders, who's a teacher, parent, and education officer. And then we introduced to them that we have an ensemble classifier that can predict and identify at-risk student. Then the question came, how are those people going to interact with that ensemble classifier while they don't have even idea about machine learning approach? So the idea came of developing a prototype in order to assist interaction of this the approach which we use. So we follow prototyping software development approach, whereby we keep on interacting with users during development of the prototype in order to ensure that we have met their requirements, and then we evaluate the prototype in order to ensure that we all meet all that requirement which was required. And we use a Flask framework to support development of the prototype. For the prototype requirement, we consider both functional and non-functional requirement. For the part of functional requirement, we check for the issue of predicting whether a student will drop or not, the issue of features with high contribution to the dropout prediction, the use of best classifier, and the issue of visualizing school dropout. For the part of the non-functional requirement, we check for the issue of scalability, usability, performance, accessibility, and consistency. And this is our developed solution, whereby this is the prototype interface, whereby user has to input student information, and that user might be a student, might be a parent or a teacher, and then via internet, it will go straight to the server, whereby in the server we have deployed our ensemble classifier, which will give back the predictive result back to the user based on those input information. So this is the input prediction interface, whereby the input student information was generated from feature engineering experiment. Those 6 well-performed features has been used as student input information, which is student gender, student age, household meals per day, a reading book status, parent checking exercise status, and parent-teacher relation. And this is predictive output, whereby it gives summary of the prediction result with the predictive result if based on the status, if that student is going to drop or not based on those input information. We have also included visualization module in order to support a visualization of schools with dropout based on those schools which we work with in Tanzania. So generally, we found that student gender shows high contribution to the dropout prediction, and an ensemble classifier which was deployed in the prototype was capable of identifying at-risk student. So as part of the future work, we plan to evaluate performance of this developed prototype, and due to the mobile phone penetration, we observed that many teachers and parents, they have mobile phone. Then we even plan to develop a mobile application based on this developed prototype. We acknowledge the support of the Nelson Mandela African Development Bank and Data for Local Impact Innovation Challenge for supporting this study. We do believe that through this study, we'll be able to identify at-risk students like Neema for early intervention before risk. Thank you very much.
Awesome. Thank you so much for that presentation. Does anybody have any questions for Neema?
Thank you. That was super interesting. What kind of intervention do you anticipate for the high-risk students?
Okay, it will depend with the nature of the environment. For instance, in Tanzania, we are facing some kind of issues. When you come to the issue of school dropout, we found that many challenges which facing students by themselves, they're associated by parents and teachers, basically. So we are planning to have a program that will associate parent, teacher, and student themselves in order to observe based on those features, for instance, interaction of the parent and teacher, and for issue of other interaction between children and children and parents to be improved in order to improve, to avoid this problem of student dropout.
like doing research with this kind of groups of kids, we can agree that they fall under the vulnerable group that can be, that may not be able to stand up for themselves, to speak out whether they want the intervention or not, whether they are on board, whether they want to be part of it or not, or even identifying them as high risk. What would happen to them? Is it going to be all for positive outcome, or what kind of unanticipated harms have you thought about that could emerge due to identifying them and due to doing this kind of research around these vulnerable groups? Am I a little clearer now?
Yeah, a little bit.
Okay, thanks.
Okay, maybe I could try to answer that question. Based on this study, we observed there are so many features that associate. When you talk about student dropout, the problem is very general, and it's touched not only students by themselves, but also those people around those students, teachers and parents and so forth. So we observe even from those features that we are not going to deal with those students by themselves, but also those people around, through them improving their status with the student. I think that will be helpful to in this kind of things. Yeah, I think help. Yeah.
All right, thank you. I think you are making the prediction from the information that was fed through the user interface, probably by parents or teachers. And I think the truthfulness or the honesty of these individuals matters on the outcome of the prediction. So how do you plan to alleviate the issues or problems that might arise from this dishonesty or misunderstanding on feeding the data on particular students?
Okay, in the prototype, it will be used by the parent or the teacher, and that parent or teacher will have those student information. So those are the people who will input those information to the prototype, and then those predictive results will come back to them based on those inputted information.